we're going to do 7-5. We're going to split it up into 2 days. Okay, now I told you every single chapter we have some kind of element of we have to solve an equation. We solved absolute value equations, linear equations, quadratic equations. What was the last one we solved? I don't know. Systems of equations, yep. Last chapter we solved radical equations. So now we're going to solve exponential and logarithmic equations. So today we're just going to focus on the exponential equations to solve. Exponential equations. And I have about 5 examples for you. So here we go. An exponential equation is when the exponent is the question mark, okay? So something like this, 2 to the x equals 8. You can solve that. Bless you. Another one. Nope. No. Gone. All right. You can solve this just by looking at it, right? Tell me what x is. 3. Good. X is 3. Okay, you just solved an exponential equation. Now, what if it's 2 to the x equals 5? Okay, that's where you use your calculator. That's where you're going to use your calculator. Exactly. Now, we're not going to do these guess and check. We're going to need a good approximate decimal answer to 4 decimal places. You're not going to want to do guess and check. So I'm going to show you how to solve these, okay? The first thing you're going to do is you're going to isolate the power. Isolate the power. And that sounds kind of weird. But the power part is like the 2 to the x. If there's anything around it, you got to get it over to the other side. Okay? Isolate just the power part. And then the second thing you're going to do, and this is what you're going to do, you have to do it to both sides of the equation, is you're then going to take the log of both sides. Because remember, when you're solving an equation, you want to do the inverse property. Like if I have x squared equals, I want to square root both sides. If I have an exponential, well, the inverse of exponential is log. We graphed it, remember? It was a log graph. So you want to take the log of both sides. All right. And then the third thing you're going to do is you're going to use this very important property that I said was my favorite property. If you have the log base b of m to the n, this is equal to, what is this equal to? N times log base b of m. That's the property that you're going to use to solve these. That's why it's my favorite, because we actually use it a lot. So, are you ready? Let's do it. Here we go. Number 1. All right, we're going to solve, and we're going to round to 4 decimal places. 4 decimals. And by the way, you are solving equations, which means you need to write the problem down in your homework. You got to write it down, and you have to show your work. Okay? Yes, anytime you're solving an equation. All right, so here we go. 16 to the 3x is equal to 8. 16 to the 3x is equal to 8. So here's what we're going to do. First, going to isolate the power. The power is already isolated. You can't divide by 3 or 16. You can't do anything to both sides, all right? And so the second step is to take the log of both sides. So we're going to take the log 16 to the 3x equals log of 8. So all I did was I wrote this equation all over again, but I put the log in front of both of them. I took the log of both sides. And then I'm going to use my property, which says I can take this 3x and I can move it down front. Yes. So 3x times log 16 equals log of 8. That's the key part to this. That's why we take the log of both sides, so that we can bring that exponent down so we can solve it now. And the rest is pretty much simple algebra. So you're first going to divide by log 16, okay, so that your log 16s reduce. You get 3x equals, and let's go ahead and divide. Wow, everybody's getting sick. Let's do log 8 divided by log 16. What'd you get?
You can't just get log half.
No. The logs don't cancel out. So it's the log of 8, whatever that is, divided by the log of 16. So you put that on your calculator. Yeah, log 8, make sure you close the parenthesis around 8. And you end up getting 0.75. And then divide by 3. So x is 0.25. This one is a nice one. It turned out to be just 1/4. It's a really nice decimal answer. Most of them aren't going to turn out so nice, but
it's a nice
it is, isn't it?
He's like polite.
Okay, so you're going to solve, do all of this in your homework. Write the equation down, solve it in a column style down your page, circle your answer at the end. Even my 7th grade nephew does that. Number 2.
Really?
Yeah, he was showing me, and Carrie, look what I'm doing. And I was so proud of him. All right, here we go. Solve. 6 to the 2x equals 1/5. Okay, it's pretty much the same problem. It's just these are going to be uglier numbers. We're going to get decimal answer by hand. So here we go. We already isolated the power. It's just 6 to the 2x, so we're going to take the log of both sides. So we're going to write log of 6 to the 2x equals log of 1/5. Okay? So isolate the power, it's isolated. Take the log of both sides. Then your next step is to take that 2x from up there and bring it down to the front. So it becomes 2x times log of 6 equals log of 1/5. All right, so now we're going to solve for x. So let's get rid of that log 6. So we'll divide both sides by log 6. So then it's gone. It reduces out. At this point, this is where I like to go to my calculator and plug that in. So let me show you what I'm doing on my calculator. I do log of 1 divided by 5 and put parentheses around that. Can you see that? No, you can't. Can you see that? No. Why is this so bad? There we go. And then I divide by the what? Log of 6. Log of 6. And so I get this ucky number, negative 0.8982. I can leave it in my calculator though, and then just hit divide by 2, because that's my last step is to divide by 2, and there's my answer. So I divide by 2. X is going to be approximately negative 0.4491. You can always check your answer back in the equation if you want to. And it's a little extra work, but okay. And 4 decimal places. 4 decimal places. All right, let's try a couple more. Number 3. Okay, suppose I have 4 to the x plus 1 equals 9. 4 to the x plus 1 equals 9. Yes. Okay, very good. See, this is the first one that we've had that our power's not isolated yet. So we need to subtract 1 to the other side to start off with. So we get 4 to the x equals 8. Now, some of you might be able to do this in your head. That would be pretty cool. But if not, that's okay. Okay, we're saying 4 to the what gives me 8. Let's take the log of both sides. Log of 4 to the x equals log of 8. Do unto one side of the equation as you do unto the other. It's the golden rule of algebra. And then we're going to take that x and move it down, because our property says that. We can do that. So we get x times log 4 equals log 8. Okay? Divide both sides by log 4. So x is, go to your calculator, plug in log 8 divided by log of 4, and you get 1.5. And some of you already got that way back here.
Yep.
Did you? 4 to the 3/2 equals 8. Isn't the square root of 4 2, and 2 cubed is 8? 1.5. Pretty cool.
X plus 1.
Yes, yes. Totally doing that one next.
Oh, okay.
Number 4. No, I'm glad you're thinking. 3 to the 2x plus 1, is that what you're thinking? Like something like that?
Yeah.
Yeah. Equals 12. Okay. Yeah, it got a little more complicated. Now, the power's isolated. You can't subtract 1. It's up there. It's up in the exponent. Okay, it's not down here next to it. You can't bring it over. So, really, the power's isolated already. So your next step, then, is to log both sides. So, take the log. We have log of 3 to the 2x. Oopsie. Log of 3 to the 2x plus 1 equals log of 12. Now, be careful. So watch this part. I'm going to take this 2x plus 1, I'm going to move it down. When I move it down, you really need to put parentheses around it because the whole thing is being multiplied to log 3. Do you see that? You're going to move the 2x plus 1 to the front, group it together, make sure it stays together, and then times log 3 equals log 12. All right, so you might know what we're going to do, like the rest of it. Here's what we're going to do. We're going to divide by log of 3, both sides. Okay, so log 3 over log 3 is 1. Don't think that the logs cancel over here. They don't. Okay? 12 divided by 3 is 4. That's true. But the log of 12 divided by the log of 3 is not 4. It's 2.2619. Okay? So you have 2x plus 1 is left over here equals 2.2619. The rest I think you should do on your calculator, right? You have this answer right here, and what are we going to do? We're going to subtract 1 from it. So on your calculator, go minus 1, and that'll give you your answer, which you already knew is 2.2619, or 1 point, sorry. That's a 1. And then finally, divide by 2. You just keep that answer in there in your calculator. You just divide by 2. And so your answer to this is going to be approximately 0.6309. 4 decimal places. They take a while, don't they? All right, you get to try one now. Yes. Number 5. I know, I can't hear anything else. I can hear no. It's that mom in me, you know, like, what? What'd you just say? All right, let's go 2 to the 3x minus 1 is equal to 5. You try this one. Let's see. You're going to need your calculator. Let's see how good you are. All right, do not add 1. Do not divide by 3. People think they do that, but they don't. It's already been isolated, the log. So you want to start by logging both sides. So log of 2 to the 3x minus 1, and do unto one side as you do unto the other, equals log 5. All right, the 3x minus 1 moves down to the front, times log of 2 equals log of 5. Okay, go ahead and divide both sides by log 2. Log 2, these will reduce, giving me 3x minus 1 equals, and I got to get a decimal approximation here. What do I have? I have log of 5 divided by log of 2. It's about 2.3219. Okay? What I like to do, of course, is to leave this on my calculator, and then I'm going to add 1 to the other side. So plus 1, hit enter, and then divide by 3. So x is approximately, divide by 3, 1.1073. Who got that? Whoa. Good. A lot of you. A lot of you did. Really good. Good.